Hello everyone, welcome back to my channel. So today again we are going to solve a problem by using the Excel solver. So let me share my screen and we are going to understand that what is the problem statement that we are going to solve today. All right, I hope that you are able to see my screen, right? So this is the problem, and first of all we are going to understand that what are the problem statements, and based on the problem statements we are going to solve this issue by using the Excel solver. Okay, now Avi, that is the name of the person, bought 10 large pieces of wood and 18 small pieces of wood. Okay, so there are two components. One is large pieces of wood and small pieces of wood. By paying rupees 12,000 in total. So he spent around 12,000 to bought around 10 large pieces of wood and 18 small pieces of wood. And decided to manufacture tables and chairs from the pieces. So what is our finished goods? The finished product here are tables and chairs. After an extensive survey of the market, it has been found out that tables would sell at a price of 16,000 per piece and chairs would sell at a price of rupees 10,000 per piece. So that is our selling price for chairs and tables. Manufacturing one table requires two large pieces of wood and four small pieces of wood. That is the ratio. So for an example, if we want to make one table, it requires two large pieces of wood and small four pieces of wood. And manufacturing of one chair requires one large wood piece and two small wood piece. How many tables and chairs should Avi manufacture so that he can able to accumulate maximum revenue? So what is our objective today? Our web is to maximize the revenue. Okay. And what are our FG? FG means finished good, table and chair. Right? And what are the components? So we can mention this as LW. LW means what? LW means large piece of wood. Okay. And SW means small piece of wood. So if we see the ratio to prepare one table, this is the line. Manufacturing one table requires two large pieces of wood and four small pieces of wood. So to prepare one table, we have a requirement of what? Two large pieces of wood and four small pieces of wood. Okay. And to make one chair, we have a requirement of one large wood. We can mention here one large wood and two small wood piece. Okay. So this is the ratio. And as of now, if we see what is the total quantity available of large woods and small woods. So if we go to the statement number 1, we have 10 large pieces of wood and 18 small pieces of wood available as of now. So we can mention here 10 large piece and 18 small pieces of small wood. Okay. So we need to find out by using all of these statements what is the optimum solution or what is the quantity that we need to produce for table and chair. Okay, so that becomes our DV, decision variable. So this is our DV that we are going to find it out by using the Excel solver. Okay, so if we prepare the mathematical model, let's suppose X equal to quantity that we can make for table. Okay. Y equals to quantity that we can make for chair. So that means in mathematical model we can mention 2x plus y less than equal to 10. 2 means what? 2 means this one. And x means what? The quantity that we can make for table. So we can say 2x plus y is what? Quantity that we can make for chair. So 2x plus y should be less than equals to 10 because that is the availability of large woods. Okay, so this is our constraint. Similarly, for the next small wood, we can mention 4x plus 2y less than equal to 18 because we have a requirement of 4 small woods for table. So that is why we have mentioned 4x and 2 small woods for chair. That is why we have mentioned it as 2y should be less than equals to 18 because 18 is the pieces of small woods that is available as of now with us. So that again becomes a constraint. Now, what should be our OFB formula? OFB is to maximize the revenue, right? Now, if we consider our selling price per piece, then for table, the selling price is 16,000. So you can mention here 16,000. And for chair, the selling price is 10,000 per piece. So you can mention here 10,000. So our OFB formula will be quantity of table that we are going to produce multiply with selling price of table plus quantity of chair that we are going to produce multiply with quantity of chair that we are going to produce. Sorry, selling price of chair that we are going to generate. Okay, so this is our formula. And previously, he already invested 12,000 rupees, right? So that we need to reduce from the selling price, selling revenue. Okay. So this becomes our net revenue. Okay. Now, if we change this constraint in the mathematical model into a formula, then we can mention here 2 multiply with x means what? The quantity that we can make for table. So this is the one plus y means what? The quantity of chair that we can make. So this is the one. Should be less than equals to how much? 10. For the next line also we can mention 4 multiply with quantity of table plus 2 multiply with quantity of chair less than equals to how much? 18. Okay. So our formula and the entire model is ready. Now we are going to use the Excel solver to get our final optimal solution. Okay, so go to the data, go to solver, reset all the values. Okay, what is our objective? To maximize the revenue. So this is the one, this is the cell where we have already implemented the formula for objective function. Our objective is maximize the revenue, so we are going to select this one only, max. What is our decision variable? We need to find out the quantity that we are going to prepare for table and chair. So we are going to select these two cells. That will be our variable cell. Now we have to add the constraint. So here we have mentioned both the constraint should be less than equals to, that is correct. Now these are the values. Click on OK. Make unconstrained variables non-negative. So again, we are going to tick this one because we want to see the production quantity of table and chair, and we do not want to uh, see any type of negative values here. So we are going to tick this one. So it will ensure that you are going to get a positive production quantity for table and chair. And as this is a linear problem, we are going to use the same algorithm, that is simplex LP. Okay, click on solve. Click on OK. So as per Excel solver table, we are not going to produce anything. For chair, we are going to make 9 chairs. Okay, and what is the net revenue or revenue that we are generating? We are generating a revenue of around 78,000 if we follow this production plan. Okay, and if you want to see that whether it satisfy the constraint or not, you can see here only 9 less than equals to 10. So this is satisfying the constraint, and here 18 less than equals to 18. So this is also satisfying the constraint that we have applied. Okay, so as per this production plan, we are not going to make any table. We are only going to make chairs, and the quantities are 9. And if we follow this production plan, this is the net revenue that we are generating. Okay. So I hope that you like my video. These are very small problems, but this will help you out to clear your foundations. As we go through the classes in the advanced sections, we are going to give some more complex problems. We are going to go through those problem statements, and we are going to find out the solutions and how we can build a model out of it. So till then, stay tuned, and if you liked it, please do subscribe and share. Thank you.